So I want to tell you a joke about UDP, but you all might not get it. Oh, yeah. Sorry, I had to start off that way. So my talk is about network engineering and how there is an intersectionality with DevOps. So network engineering has gone DevOopsie. And the inspiration for this talk came from my years of spending a lot of time working in data centers, plugging in cables, configuring routers and switches, to fast forward to today where I'm literally configuring a bunch of YAML, and then there's my networking. So it's a very interesting journey that I've seen, and quite honestly, I'm really here to say that if you're a network engineer here, you have a place in DevOps. So let's get into it. My name is Marino Wijay. I'm a developer advocate at solo.io. I will do a pitch on Solo tomorrow, so I'm not going to get into the details about it. But if you want to follow me on Twitter, you can. If you want to watch me live stream, I do it every Friday, and I just dig into a variety of different technologies. But it's mostly around like networking and DevOps. So this one's going to sting. So you might have overheard somewhere that service mesh is just a VPN. That was me, sorry. The reason for why I said this was because when I think back to a lot of network technologies, especially ones that I've played with, IPsec, SSL, they are VPN-based technologies. But fast forward to today where we are working really hard to protect our microservices and provide some level of identity and authorization and even encryption. To me, that all just looks like a VPN at this point. Now, I don't want to dumb it down and simplify it to just a VPN, but the idea here is that we've come full circle. We've gone cyclical here, and we're leveraging the same patterns that we have many, many years ago today in DevOps, in the world of containers, Kubernetes, and everything associated with it. So for me, it all really started with, this time I got a computer, a desktop that I happened to be, playing around with. I didn't have any internet access, and at the time, like, it just made no sense for me to try and cable up things, like set up Cat5e up and through my house and then try to get that connection. So I looked into wireless, and at the time, 802.11b was the shit. So I showed up at my local computer store, picked up a wireless B router, a NIC card, and tried to make it all work. And then somehow word got out, and I was doing this for all my friends and family. But what was really interesting and fascinating was, plugging and praying was great, but really understanding how we would configure these devices to move packets around was much more fascinating. And I had no idea how this all worked out. So the way it worked for me is I started at the bottom with the OSI layer and I worked my way up. Let's continue on. So I want you to imagine an OSI model for a second. Actually, I won't do that to you. Here is the OSI model. I would never do that to you. It's too complex. And to be honest, there is also a TCP/IP model that exists. But for the sake of understanding, for the sake of being able to clarify things and make things much more cohesive, especially in the world of networking today, the OSI model still is relevant. So let's just quickly trace through the layers, and then we'll dig into more stories and fun stuff. So we start at the physical layer, where we are literally plugging in cables into physical devices, and we're watching things light up. But that's just it. I mean, there are signals going around. There are electric signals, ones and zeros, binaries all over the place to help us move data around, make decisions, and whatnot. But as we climb up, as we go up that stack, we need to provide some level of intelligence to tell systems where other systems live and how to get to them. So this is achieved through things like switching and routing protocols, and then so many other things like DNS and whatnot. But 10 years ago, we're 2022 now? Oh my gosh. Yeah, we're 2022. Okay, so let's actually go further back. 14 years ago, when I started to dig into this world of networking, for me, it was just about plugging in a bunch of switches, but I didn't know a thing about VLANs. I didn't know about MAC addresses. I didn't know how ARP related to IPs and MACs. I didn't know how DNS worked. None of that, but it all became relevant and came to head when I started to realize that if I wanted to manipulate my traffic streams, if I wanted to manipulate the way I had point A communicating with point B, I needed to make those changes. I needed to drive that logic somewhere, and so I started to do this at layer 3 and layer 4. And then when you climb up this stack, we start to realize that if your system responds with an HTTP 418, what is it telling you? It is telling you that it has decided it does not want to serve responses or serve up requests anymore because it is a teapot. Go look up the HTTP status code, 418, and you'll see what I'm talking about. But the idea of having the status code is to provide us a meaningful response of what is actually going on with that application. Did we get a 200? Why did we get a 200? Did we get a 500, 503? Did we get a 404 not found? But these are much more oriented towards that user experience because guess what? At layer 7, we start understanding things, understanding what's going on. But this gives us a layer in which we can drive some additional intelligence. Now, fast forward to, I don't know, 6 years ago, 7 years ago. How long has Kubernetes been around? 7? Yeah? 2015. So 7 years. It started to drive the way we started doing networking because networking was around desired state, and we wanted to make sure that we would align the way Kubernetes worked with the way networking worked. And so we started to come up with technologies like the container networking interface layer, API gateways, proxies, and even service mesh technologies. But that's not what it's all about. It's about the whole pattern, right? The whole, how did we get here? So how many of you have chased networking certifications before? Yes. I have chased that dragon many, many years ago, and I enjoyed it, but I got bored of it because I started to realize that the value isn't derived from reading a bunch of books and taking a bunch of tests. It's actually playing around with this stuff. And so I found myself working my way through a campus network, building out wireless networks over to a DC, messing around with storage array networks, trying to do fiber channel zoning and everything in between. And then, oh, by the way, iSCSI shows up and says, hey, we need to use MTU 9216 to make sure that our packets move all the way through. And you start to think about these things, and your networks are becoming far more complex. Your networks are creating this level of, I have configurations for this device, for that device, I have structure, I have infrastructure, I have architectures that cover a variety of different domains in networking, and none of it is cohesive, none of it is collapsed, none of it is stitched together, so it seems kind of messy. And so we have something like this. We have the situation where you walk into a data center or a campus network and you have Cat5e spaghetti going everywhere. And then, oh, by the way, you have unpatched firewalls. You have iOS versions that are out of date by 20 plus years. And then you start to realize that maybe it's easier to deploy RIP instead of BGP. Not really. And then there's this other movement that comes along and says, hey, I can virtualize your networks and layer on top of that trash you just built like many, many years ago. And that is SDN. So with software-defined networking, we kind of took this realm of let's automate everything. Let's leverage technologies like REST to drive configuration and even desired state configuration to a degree. But the nice thing about that is, okay, we're removing a lot of that toil. We're removing any sort of human error, and we're allowing some systems to kind of drive a lot of this automation for us and build our networks for us just in time. So, you know, we have this movement of SDN, we have this movement of SD-WAN, we have, you know, configurations that allow us to automate, systems that allow us to automate the way we deploy our networks, and that's just because devices probably 5 years ago, maybe even a little bit more than that, supported this ability for REST, for API, for us to be able to define our configuration, pass it in through something like an Ansible playbook, and then that gets deployed right into your device. And companies, vendors like Cisco, Juniper, and others were making bank off of this. And then you have companies like AWS, VMware, Google come up with their own little private cloud technologies that virtualize everything, that create these just-in-time networks for us without having to touch a device. Well, you have to touch a bunch of x86 servers, but you get the point. And then you have these movements where, you know, you get an email from Kirk Byers saying, hey, sign up for my Python automation course. And I sit there and I think, why do I need to learn Python for? But then you start to realize that Python is a backbone for network automation, along with systems like Ansible, along with systems like NamePalm and Nornir and others as well. So what we're really doing at this point is we're trying to drive away from configuration error, right? We're trying to move away from inconsistency in the way we deploy our devices and our networking stacks. Sound familiar? Does this almost sound like CI/CD-ish? Right? Except what we don't want to be doing is like a GitOps approach to networking, because when I make a change in Git, I don't want it to suddenly show up in my networking device because, oh, by the way, that could literally screw things up and I might have an outage. So, you know, come full circle, we're doing automated VPNs with IPsec. Oh, wait, VPNs again, why did I keep bringing that up? And it's because we are going in this pattern, this cycle where we still need to move packets around. We just need better layers of abstraction on top. And so several people have mentioned this already. Like we are building these systems on top of other systems. We're building these abstractions, but why? To simplify how we go about building our applications, to simplify how we build our networks. And that's why things like SD-WAN came about. You know, it removed the need for us to have to sit there and leverage Git or leverage some source control. We drive our configuration to a system that will then in turn push that down to devices. And we make our changes pretty quickly and easily without impacting anything. But for me, right, you know, 12, 14 years ago, when I had like 20 different router config files on my laptop and I stored like some of them on some file server and I tried to uncover them and try to figure out where they were, I realized, where the heck was Git when I needed it? Like, where was this tool? Like, Chris, tell me, where was this tool for? Right? Exactly. So the thing is, for network engineers back then, we didn't have this source control capability. We didn't have the ability to collaborate on network configs much like developers do today. And quite honestly, I'm glad we do today. I'm glad we have this available to us because it makes network configurations much more easier. It makes them streamlined. But it's not just about that. There's so much more. Git is just one part of that story. It's also where we went. So who is Kubernetes, or who is Kubernetes, or what is Kubernetes? And I'm sure y'all know about it, so I'm not going to dig into it. But it created this paradigm shift in how we go about developing our networks. Because guess what? When you create that container, deploy it, and it runs as a pod, and then when that pod gets destroyed, it's not retaining the same IP. So we're throwing outsider routing all, you know, out the door, out the window. So how is this relevant to networking anymore? Because we're still moving packets around. What we really need to care about is things like DNS, things like labels, and things like YAML. Unfortunately, we kind of need to know YAML to be able to configure a lot of what we're trying to configure. But it paved the way to be able to create some very, I would say, just-in-time networks that are robust. They can spin up, they can spin down when we need them, however we need them. But it created a very quick approach to saying, hey, I want to spin up an app. As long as I had a CNI layer, I can get my app to communicate pretty well. So, you know, when we think about it, let's fast forward a little bit. So we're at this stage where we have Kubernetes, we have networking technologies, we're trying to merge them together. And, you know, in the world of containers, how did we network them? We had networking namespaces, but that evolved into container networking interfaces. But we realized that it wasn't just about that. Remember that layer 7 intelligence I was talking about earlier on? How we're able to discern things like identity, any other kind of metadata or information inside of that header. Well, unfortunately, our CNI layer can't take care of that. Layer 3 and layer 4 is very limited. And so we need something higher level, something a little bit more intelligible. And that happens to be things like a proxy or a service mesh or an API gateway. But what I'm really working towards here is that when you think about how you build out your applications today, it's not just about, hey, I have a switch and I can move packets around. You actually need a full stack of networking to be able to accomplish what you're trying to do. Because guess what? When you're trying to do CI/CD, or you're trying to provide higher levels of availability, or you're trying to delay certain services from communicating with other services so that you can provide a very resilient application altogether, at the end of the day, it's networking technology that makes this all possible. So networking namespaces to CNIs, to service meshes, to API gateways, to proxies. All of this comes down to the fact that this was all possible because of networking technologies, and also actually because of Linux and the way Linux was designed. But what it really comes down to as well is that, hey, if I really wanted to spin up my just-in-time network, I could actually do this with YAML pretty darn easily. The other thing too is I wanted to call out a particular pattern here, right? So when I joined VMware back in 2017, I worked my way through the world of software-defined networking and VXLAN and Geneve and NSX and ACI and all that fun stuff. But the thing that stuck around was the ability to determine what your routes were, the show IP route command, or the equivalent of it wherever you were. Things like BGP never disappeared because, guess what? We still need to get to our remote networks, and we still need a protocol that is scalable enough to be able to handle so many different networks that exist in the public space. But when you think about show IP route versus something like Istio-CTL proxy config routes, their outputs might look different, but they're providing the same set of information. How do I get to that destination? Now, what's interesting about this is they look the same. So for a network engineer like me, that looks the same to me. When I'm able to read that, that means I'm understanding how packets are flowing in the world of containers, app dev, and you know, everything around it. So let's think about this for a second. We're now starting to put YAML around, and we're starting to put networking in our YAML. Like literally, you will look at a YAML configuration, and you'll have BGP peering set up. You'll have a BGP network configuration set up so that you can start sharing your networks. You'll have network policies in place. You'll also have this ability to start routing at layer 7. And this can all be achieved with YAML. And what's really fascinating about this is it's kind of become the love language of, and sorry for saying that, but it's kind of become the love language of being able to work with the world of DevOps. And this becomes very meaningful to someone like a network engineer like myself, because I look at configurations. If I looked at an iOS configuration, I'm able to discern what's going on. If I look at a YAML configuration, I'm able to determine what is going on. If it's networking, I'm able to get it. I'm able to figure it out. But what's more critical is that what has happened with the world of Kubernetes is it brings all the networking things back. You're going to see things like ports, protocols. You're going to see TCP, UDP, routes, BGP, layer 7 destinations, HTTP codes, whatever it is. But that's all networking. So it all stays the same. It all stays there. It just looks a little different. And so let's come full circle to say that service mesh is just a VPN, but is also a very important network layer that we need. And the reason why that is because when you go back 14 years ago and you were trying to determine why there was latency between two endpoints, what were you doing? What were you using? Today, we have tools like Kiali and Jaeger to be able to give us that information, to be able to tell us the request flow from the moment that request enter that whole flow all the way to the responder and that response that is sent back. But that's just me looking at Wireshark, but with a different tool. That's me just looking at TCP dump, but with a different tool and looking at different information, trying to discern the same thing. So I say this all to say that while service mesh might just be a VPN, it's much more than that. And I say this all to say that network engineering, while it has gone DevOopsie, while we have, intersected, if you are a network engineer today and you are trying to move into the world of DevOps, there is a place for you. If you are a DevOps practitioner or an SRE, there is a place for you to go understand networking, because the two worlds work very well together. They work hand in hand. And with that, I say thank you. One thing I will say is that if you are interested in digging into the world of networking, or if you are interested in digging into the world of DevOps, there are 3 resources that I have for you. Networking and Kubernetes, one that I look at as my Bible, kind of. I just go reference it whenever I can, because it has a lot of valuable information from the beginnings of networking all the way out to how are we doing this with Kubernetes, to one of my great friends, Kunal's course. He built a computer networking course that takes you through how networking works, but at a little bit of a higher level. It's a 4-hour course. And then there's one more called Istio in Action, a slight plug for my boss, who actually wrote a deep book on how service mesh works with like real examples. So I just want to say thank you all. If you're trying to figure out how networking works, just follow the packets.